Hey Toils, welcome to our first video here on data. Right, this is topic DS4, and today we're going to look at collecting and displaying data. Now, you've seen most of these things before, and hopefully you remember, but it's easy to forget. So just a quick refresher, we want to classify data to begin with, right? Types of data, not an entirely unknown HSC question. Right, what sort of data is this? How do you classify this? Now, broadly, two things, categorical or quantitative, right? Is it a sort of a type, or is it an amount? Okay, types, categories, amounts, quantitative. Now, each of those can be broken down into two subgroups as well. Now, nominal data is the name of something, right? Those different data points, different datums, don't have any particular order between them or anything like that. So, for example, what's your favorite color? Right, that's nominal data, right? I like to structure this as a question, and I think, what sort of answer am I going to get? Okay, what sort of things might you say? Who are you planning to vote for in the next election? Well, secret ballot. But nonetheless, while those things do appear in some sort of order on the paper, really, you're after the name of something, right? There's nothing else that connects that data, they're just names. Next, after that, ordinal data, and often the tricky one to remember and to classify, but ordinal data is stuff that goes in order, right? It's easy from the name, order, like your current ranking class, right? Or it can be things like shoe size. How big is size 8? It's not 8 units of something. We're not counting something, we're not measuring something. It's indicative, right, that an 8 is bigger than a 7, smaller than a 9. Small, medium, large, that sort of stuff. Good examples of ordinal data. Now, our quantitative data, right, can be either discrete or continuous. This is discrete with ETE, not double ET. Discrete data, stuff that you count. Right, now they are distinct separate values. That's good language. They're distinct separate values. You go straight from one to the next with nothing in between. How many brothers do you have? Maybe you've got 1, maybe you've got 2, maybe you've got 3. But there's nothing between those, or 0. There's nothing in between those values. No one has 0.7 of a brother. Yep. Right, they jump from one to the next. Things that are counted. And we use special language. Things like the number of something as opposed to the amount, or how many of something as opposed to how much. Right, those alternative language sort of indicators there belong to continuous data. This is stuff that's measured on a continuous, a smooth scale, where there's always something in between, potentially. We use this, how much, sort of words when we're dealing with continuous data. It will just about always be measured using some sort of device and with units displayed as well. So we can have weights of different football players, right? I can put those. I can easily sort of organise those. Now, if someone is 105 and someone's 106, well, there's a weight in between that, like 105.5, for example. But even if I had 105.001, 105.002, there's always potentially something else in between. That's continuous data. Would measure that using a set of scales, and we would give units of kilograms or something like that. That's usually an indication that it's continuous data. Right, that's 4 classifications. Let's have a look at how we might use these in an example quickly. Also, graphs. What's this thing? Generally, I would call this a column graph, even though it's on its side. A divided bar graph and a sector graph, not a pie chart. Now, discrete data often works well with a column graph, okay, because they have very particular finishing points, right? Small data sets, dot plots, that's this, or a stem and leaf plot, can be good. To be honest, you don't see a lot of stem and leaf plots outside of maths exams. Other things, pretty useful. Now, continuous data, sometimes, is best displayed on a line graph. Good for indicating a trend where there is something in between. Now, radar charts are a special case here, and I tend to only like those for cyclical data collection. So if I want, say, the average rainfall in Maitland per month over the course of a year, right, because December is next to January, but if I want to just record the temperatures today, or the temperatures at different points throughout today, going from 11 o'clock at night till if we start here at sort of, let's say midnight last night, we work our way throughout the day, and I come back to 11 o'clock tonight, why would I join that up? Really, it's where it goes around and around and around is best, but you will see it sometimes really used like a line graph but in a circle. So, data set described below. The number of people, now that's a key word there, number, almost always means that it's discrete data. The number of people, I'm going to count them, attending different sports at the Olympic Games, so that is discrete. Oh, sorry, we need to call it quantitative discrete. There's no other type of discrete, but anyway. Quantitative discrete. And in that case, what would be the best there? I think a column graph would represent that data nicely. All good? Types of breakfast cereal on sale. Well, types, there's a bit of a keyword there, probably suggests that it's categorical. Categorical? Yep, and if I sort of think about it a bit more, yes. Types of breakfast cereal, maybe these are, like mueslis or corn-based or rice-based or something like that. Types of breakfast cereal on sale in supermarkets. So this is going to be categorical, nominal. Because if I say, what type of cereal do you have on sale? I get a name, nominal. And what would be best to display that? It sort of depends on the context, but I think a sector graph would be good there, right? Because that's going to show relative sizes of those types. Sector graph, I quite like for that. Although, you might need to justify that. Depends on the context, as I say. Now, the body temperature of a hospital patient over a 24-hour period. I think there's a suggestion that this should be a radar graph, but I don't like that. But I measure the temperature. I measure the temperature using probably a thermometer in degrees Celsius, probably. That is measured is quantitative, continuous, and I like a line graph for that. Line graph, and I think that if you go to a hospital, you will see exactly that. You will see this sort of information kept on a line graph. Nursing is what you're interested in. Hey, line graphs, trust me. Okay, that'll do us for this. Check that out. I'll see you in class.